Paging and segmentation are the two important concepts in virtual memory. The process of dividing an entire process into a fixed size of chunks is called as pages, and this process of dividing it is called as paging. In main memory, the process is stored in several frames where the entire process is divided into a fixed size of chunks called as frames. So, in virtual memory, a page is mapped onto the frame in main memory. This diagram shows the relationship between a frame and a page. Let us consider there are 15 frames available in main memory, and there was a process A which occupies 4 pages in virtual memory, namely A0, A1, A2 and A3. Each of these are the page numbers in virtual memory. The 4 pages of the process A is loaded into 4 frames in main memory. The frame numbers occupied by process A in main memory are 0, 1, 2 and 3. So, it clearly shows the process A of page 0 is loaded into frame 0 in main memory. Similarly, process A's page 1 was loaded into frame 1 in main memory, and so on. Now, a second process, namely B, it occupies 3 pages in virtual memory, is loaded into the main memory in the frames 4, 5 and 6. Like this, any number of process that is mapped to a certain pages in virtual memory can be loaded into the frames in main memory. Whenever those pages of a particular process is not necessary to be residing in main memory, they can be swapped out so that some other pages of another process can be loaded into the main memory. So this is represented in this diagram under the section E and F. So in E, the process B has been swapped out. That is, 3 frames occupied by process B is swapped out, and another process called D, which is of 5 pages, are loaded into the main memory in 2 different frames in main memory. The first 3 pages, that is D0, D1 and D2 of the process G, is loaded in 4, 5, 6, and the pages D3 and D4 of the process is loaded in frame 11 and 12 in main memory. So in order to maintain or keep track of the details of which pages of which process is loaded into which frame numbers in the main memory, the operating system maintains a table called as page table. This is the structure of a page table. So here 4 processes are shown along with the free frame list. Process A is stored in 4 pages, which is mapped to frame 0, 1, 2 and 3 in main memory. Similarly, process B was not loaded into the main memory, so the frame numbers of process B was left empty in this table. Similarly, process C has occupied frame number 7, 8, 9 and 10 in the main memory, and process D 4, 5, 6, 11 and 12 in the main memory. Other than the list of the frame numbers allocated for the pages of every process, there was a list maintained by the operating system called free frame list. So those frame numbers which are not occupied by any pages of a process are listed in this list.